we're going to do is we're going to do functions and their graphs. In this case, what we're going to have to do is you guys are going to have to use the graphing calculators provided to you, or go to the graphing calculator link I provided to you on our Canvas page. Okay, I'm going to show you how to get to that once again on here in case you forgot. But we're going to use the function notation to represent and evaluate a function, find domain and range of functions, sketch a graph of a function, types transformations involved with it, and classify the functions and recognize a comment of functions. Oh, that seems pretty easy. Let's see how easy it is. I might not even need my computer. Now, here is the deal. First thing, step one. Oh, I don't even. Now, what you're going to have to do is think of three forms. The first form is implicit form. Okay? You guys know what implicit form is? If you know it, yell it out. Good. I just heard you from wherever you are. You said it's when the x and the y are on the same side of the equation. Okay? X's and y's, both on the left side of the equation, both on the right, and whatever number values you have is on the right. All right, so if you have implicit, you also have explicit. What do you think explicit is? Yell it out. Some of you are right. It is when you're, what do you got? It's all by himself over here, or herself. The y. The y is all isolated by itself. It's when you're solving for y. And what we care about, what we're going to transfer to in calculus, implicit, explicit, that's baby stuff. That's pre-calc. Now we're in the big leagues here, okay? Major league. What you guys are going to do is use something that begins with an F. U. N. Good. Function notation. Now, what do you do with function notation? Do you guys know? You take that y and replace it with a f of x. So your answer is f of x equals 1/2 1 minus x squared. Now, in this situation, ready? You just have explicit form. You just switch the y with an f of x. All right? Ready to learn some facts about functions? Oh, is this domain and range? This is the funnest of the lessons. This is going to be one of your most hated lessons of the year. So, I'll just give you the answer to the next one. See if you pay attention. Every function has to have a domain and a range. Now, you also have two types of variables with domain and range. Now, your y is not a range variable. I'll give you a hint. It is 4 syllables. Begins with an I. N. D. Very good. Independent. So, where am I at here? So, oops. You didn't see that. Y is in, whoops. Shh. I never said that. Y is the dependent variable. And what does y depend on? It depends on x. I was too busy counting syllables there. I mixed the two up. So, what you do is pretty much you take your x values, you plug them into the equation, and based on your x values, you're given a y value. Now, why is this important? This is very huge importance because it is how we're going to determine what domain and range is, okay? Domain is your x values, okay? So that is your left to right, okay? So your left to right is your domain, your range is your y or your f of x values. And that's the distance you go up or down. So what you do when you're dealing with equations, okay? This is how you solve equations. You take whatever x is, you plug it into the equation, and that's how you get y or f of x, okay? That's why you have f of x, the function, when you plug x in. All right? You don't do it really backwards. Anyone know what kind of test you may have to use too? Oops. You may have to use a vertical line test. What does that mean? It means there can't be more than one x. So pretty much if you have a line, if x equals 2, you can't have another time where x is going to be 2. So your line just can go across. It can't really backtrack. All right? That is not a function. Okay? If that's true, everything goes bonkers. You can have two y's, like a parabola. That's okay. Like when you square x, you can have plus or minus y's. All right? So, square root x, I said. For the function, ready? We're going to start very simple. Once again, back to algebra. Build our way up to the difficulty. F of x equals x squared plus 8. Evaluate each of the following 5 expressions. Ooh, you like that expression? That's derivative. We're going to get up to there. Don't worry. They're going to be fun. All right, so go. In case you're wondering, f of 2 means just x equals 2. That's what that 2 means. So it means wherever you have an x, you plug in a 2. 2 squared plus 8, which is 4 plus 8, which is 12. All right? If you now understand it and you messed up before, redo them. All right, problem 2. 4a squared. Now, tricky thing, when you square 4a times 4a, the answer is not 4a squared. It's actually 16a squared because you're squaring the 4 and you're squaring the a. So it's 16a squared plus 8. But you do that, right? D plus 7. D plus 7 squared plus 8. Not d squared plus 49 plus 8. We have to square the quantity d plus 7. So we're going to have to use 4 letters. F. O-I-L, foil. All right, so d plus 7 times d plus 7 is d squared. D times d is d. Plus 7d, plus 7d, plus 49. I just have an imaginary d plus 7 over here. Combine like terms. 7 and 7 is 14. 49 and 8 is 57. All right. X cubed. X cubed squared. It is not x to the 5th. It's x to the 3rd times x to the 3rd. 3 times 2 is x to the 6th plus 8. All right. See, not as easy as you thought. You may have made a mistake or two, but now you remember. Number 5. Uh-oh. What does this mean you have to do? This means you're going to have to take this equation, plug this stuff into it, subtract this equation, and divide it by this. What? So, x squared plus 8, x plus delta x squared plus 8, minus, well, it says f of x is this, so minus this over delta x. Foil this. X squared plus 2 delta x plus delta x squared plus 8 minus x squared plus 8. Does anything cancel out here? X squared minus x squared becomes 0. So you're left with 2x delta x. Oh, and 8 minus 8, 0. 2x delta x plus delta x squared over delta x. What goes into all 3 of these? I'll give you a hint. It's delta x. You like my hint? Nice, good hint. So, cancels out, and I take one of these 2 away, because I had delta x, so I take 1 away. 2x plus delta x divided by 1. So just 2x plus delta x. All right? And that's it. Look at that. We solved a derivative already. 3 months ahead. 2 months ahead. 1 month ahead. 3 months ahead. From limits then derivatives. All right? Let's move on. Let's go further. All right. This is a review that I had to throw in a little whiles back because people forgot how to rewrite the equation. So the way we're going to write stuff is the way you're supposed to write it. The way that, once again, the big boys and girls write. Not like the elementary kids and the middle school kids and even the 11th graders. How you're supposed to write it. So x1, every number blank but does not blank x1, which is just subscript 1 or x subscript 2. That just means both 2 points. So x1, x2, it's every number between the 2 x points, but does not include them. So when you see this, this means x is less than a number or x is greater than a number. That's what the parentheses mean. It's like if you have an open circle. Now these are just x values, so it's just a horizontal line. All right, so it's just a horizontal line for all this stuff, and you're just giving x values, okay? So you're going from here to here. You're less than here. You're greater than here, okay? If you have the brackets, it's every number, once again, in between those 2 numbers, all right? But it includes those 2 numbers. So the bracket is like a less than and equal to or greater than or equal to, back in algebra. So that's if you had a circle that was closed. So it includes those points, all right? If you see in parentheses x to infinity, x is your smallest number, infinity is your largest number, so it's every number greater than x. Negative infinity to x is every number less than x. Now, why do you have to use parentheses for infinities? Well, technically, there is no number infinity, because every number that gets to infinity, you can always add more to. You can't get to the biggest number ever, because there's always a number big. All right? I don't care what YouTube videos you watch to say you found the biggest number. It's not true. All right? They're all liars. Next one. Number 6. I want you guys now to 6 through 9. See if you can graph rewrite these equations in this form. Use the number lines to help you at first. All right, and this isn't going to be one of our lessons. This is just going to be how we're writing, so it's important that you learn this. All right, so for number 6, hopefully you do this, x is less than 2. So you put a little and greater than or equal to -3. So I have -3 here, and I have 2. All right, greater than or equal to -3 means closed circle, everything bigger, right? Less than -2 or less than 2 is an open circle and everything less. If it is and, it means it has to be true for both of these. So where do these lines overlap is what we're looking for, that overlapping spot. All right, so the way we would write this is x is greater than or equal to -3, so that would be a equal to, is that a bracket or not? That is indeed a bracket, -3 to 2. And since that's open circle, that would be a parenthesis. That's all there is to it. All right, number 7, less than 4. So you have 4 here. Less than goes which way in the number line? Very good, to the left. So it's every number less than 4. So from -infinity to 4. Good. 8. Less than or equal to 0, greater than or equal to -10. So I got -10 and I got 0 on my number line. Greater than or equal to -10 is a closed circle to the right because it's greater than. Less than or equal to 0, closed circle and less than. Overlapping parts both include closed circles, so they're both going to be brackets from -10 to 0. All right. X is greater than or equal to 72. Put 72 on your number line. Greater than or equal to goes. Good job. Whoop, you see? That way. So, close bracket. 72 all the way to infinity. All right. Any questions? Hopefully not. Hopefully you guys are doing good. You're doing good. All right, let's read these things. Let's write this like this form. So, I already gave you the first step. Greater than 3. Up to 8 included. Oh, this one's a tricky one. Less than, so it's -8, -infinity to -11. And this is -2 to infinity. And in between you put a U standing for union. You remember union? That just means it's true for both cases. It's true for this case and this case. It's like an or. Remember when you used to do the or? It's this or it's this. So union means it's both. Okay? Awesome. You thought you were done with unions, didn't you? All right. Do now. Here's the do now you're supposed to be doing the next day. Plugging in your stuff. So let's see. You plugged in -3. -18 minus 7 is -25. Next one, you plug in 5. 3 times 5 squared plus 5 times 2. 75 plus 10, 85. This one got some in. -50, radical 2 times 50 plus 3. 2 times 50 is 100. So it's -50 times radical 100 plus 3. What's the square root of 100? 10. -50 times 10 plus 3. Use your PEMDAS. -50 times 10 is -500 plus 3. -497. Parentheses. Exponents. Multiplication, division. Addition, subtraction. PEMDAS. Got it? Alright, we did that, and this was the homework you were given. Ready? Let's see if you got the homework. 7 times 0 minus 4. You're just plugging in this stuff into that equation. 0 minus 4 is -4. 7 times -3 minus 4. -21 minus 4 is -25. Look at that. You're just looking away. B. What do we do with the... What's that mean, B? Well, we just plug the B in there. 7b minus 4 is 7b minus 4. Haha. Easier than you thought. X minus 1. 7 times x minus 1 minus 4. Distribute the 7. 7x minus 7 minus 4, and then combine like terms. -7 minus 4 is 7x minus 11. Got it? Awesome. Number 2. Plug in the stuff. -4 plus 5 is 1. Square root of 1 is 1. I'll move over here for this. 11. Square root of 11 plus 5 is the square root of 16. Square root of 16 is 4. -8. Square root of -3 is, can't take the square root of a negative number. We do not deal with i's and imaginary numbers in this class. That is no. When you get the more advanced calculus you do, not in Calc 1. So, we're going to say undefined. Anytime you see a negative under a radical, undefined, not radical 3i. Okay, we don't want to deal with i's. Even though I times I, what is it, radical, I times I is negative radical 1. No imaginary numbers here. All right, anyway. 3. 4 squared, 4 minus 4. 16 times 0 is 0. 3f's. 3 squared is 9 over 4, 9 over 4, times, this is 3 over 2 minus 8 over 2, so it's negative 5 over 2. 9 times 5 is 45. 4 times 2 is 8. Negative 45 over 8. All right? And as you guys will see, I just teach you as if you know nothing in this class, which I know most of you guys do know a lot, and I don't have to explain step by step, but there may be one or two you guys that forget. That's why I play down to the lowest as if you don't remember anything. So, because I forget a lot of stuff, and I teach this every year. Plug the c in there. C squared. Oops, sorry. See, I forgot where to point. C minus 4, distribute the c squared. C to the third minus 4c squared. Problem number 4. Sine pi. Type this in your calculator. Your calculator, anytime you have trig, has to be moved to radian. If you do not put it in radian, you will get the wrong weird answer that's like 0.0007 something. No sense. Sine pi, everyone knows, is 0. Or you can break out your unit circle if you choose to. I wouldn't do that now. Radians. All right. Sine 5 pi over 4. Make sure this is in parentheses when you put it in your calculator. Negative 0.71. Sine 2 pi over 3. Negative 0.87. All right. I think one of them is like radical 3 over 3. But decimals are fine. Ugh. Ready. Put in the cubed. X plus delta x cubed minus x cubed. This was the one to get you guys. Hopefully you didn't give up. Blah, 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 blah. All right, so in this case, a plus b cubed equals a cubed plus 3, a squared times b plus 3, b squared times a plus b cubed. What? In class, I went over this long on the board, and you guys actually got it. But in case you don't, this becomes this. Now let me explain. A cubed plus 3 times a squared, x squared times delta x, plus 3 times delta x squared times x, plus delta x cubed, minus x cubed. X cubed minus x cubed cancels out. 3x squared delta x plus 3x delta x squared plus delta x cubed. I could take this little guy out, take all of them out, take one of these 2 out, and one of these 3 out. Leave me with 2 here. That's big 2. 3x squared plus 3x delta x plus delta x squared. All right. This one, yeah, I know it was tough, but can't give you all easy stuff, can I? Calculus. You guys are supposed to be the smartest people in the school. Supposed to be. We'll see about that, right? All right, so domain and range of a function. Find the domain and range. Do. This is what's going to separate us. Unfortunately, after the next couple slides, we're going to be missing a couple people. Now, problem number 12. You know what that means. Bye-bye. All right, domain. Domain is your what value? X, right? It goes from left to right. So being that these arrows go up to infinity, right, in both directions, they actually expand out in both directions. So they go this way. So your domain is all real numbers from negative infinity to infinity, all real numbers or this R sign. Now, I know, listen up before you think you're smarter than me, this should have 2 dashes down and just one thing going over here. But I looked it up online. They use this as the all real numbers formula too. Right? I didn't believe it, but I looked it up. I was going to make my own R. But that's what they're using. So, hey, that's all real numbers. Range. Range is your up and down. So the lowest point here is -1, and this goes up into infinity. So it's -1 included, because it's closed, to infinity. Graphs are easy. Problem 13. Go for it. Boom, you're done. Domain. 2, open circle, right? 2 to infinity. What's my lowest point here? 0 up to infinity. Right? Now, here comes the fun. Problem 14. Square root of x minus 1. What is the domain? Now, the way to do the domain here is fairly simple. What are the values I could plug in for x that will give me an answer? Okay, if I plug something in for x and I get undefined, it is not my domain. Okay, this is the easiest way to do it, just to teach you. So, if I plug in a number and it gives me an undefined answer, it's not my domain. So, what do you have here that's bad? I'm going to say bad, it's not really bad, but what will give us a bad domain, undefined domain? It's a radical. Anytime you have a negative under a radical, our answer is undefined. That's bad in this case. Undefined means you have no domain there, okay? It means like a blank space in the graph. All this stuff right here would be undefined if I plugged it into whatever this function is. So, when is this stuff here not negative? When something is not negative, it is two things. So, negative when there's no domain. So, we need it to be positive or 0. A number that's positive or 0 is a number that's greater than 0 or equal to 0. So, whenever x minus 1 is greater than or equal to 0, your answer has a domain. If you don't believe me, what number is greater than 0? First, let's solve for x. We add 1 to both sides. So anytime x is greater than or equal to 1, or using this formula right here, equal sign means box, 1 greater than means it goes to the right, that's to infinity. Anytime your x falls in here, you get an answer. Let's pick a number. Let's pick 2. 2 minus 1 is 1. Square root of 1 is 1. 10. 10 minus 1 is 9. Square root of 9 is 3. Okay? A billion. A billion minus 1 is 999,999,999. Square root of that is definitely positive. Let's pick a number that's not greater than 1, like 0. 0 minus 1 is negative 1. Square root of a negative 1 is negative. Negative 10. Negative 10 minus 1 is negative 11. Square root of a negative is undefined. Okay? Sorry, I should have said undefined before. So this is when your answer gives you an answer. Now let's see what answer gives you. Range are all your answers. That's all the things f of x can be. Now, it depends on what your answers are. So let's look right here. What are the only possible answers for this? So, the smallest number we can have here is 1, right? If we put 1 in here, 1 minus 1 is 0. So square root of 0 is 0. So our range could be 0, or it could be any number that's positive. Because you can never get a negative answer as the square root of something can never be a negative. So our range is 0, or all positive numbers. 0 all positive numbers, how can we write it like this? Any number that's greater than or equal to 0. All right? Not too shabby, right? No? Why don't you guys try 15 and 16? I just got to get the charger to make sure my computer doesn't die. All right, next one, you're dealing with a fraction. When you're dealing with a fraction, what do you have to do? Anyone? You know that any number over 0 equals what? Anyone? What is any number divided by 0 equal? We just said it before. It is undefined. Are undefined numbers good? No, they are bad. Come on, man. Sorry, I'm just charging up my thing. So, anytime you have the bottom, the denominator, equal to 0, not greater than 0, not less than or equal, but just a straight up equal to 0, your answer is undefined and you get no domain. So, when x squared minus 9 cannot equal 0. When it equals 0, it's undefined, so we want to know all the time it's not equal to 0. All right, the easiest way to find out when it's not equal to 0 is find out when it is equal to 0. So we add 9 to both sides and we square root it. So when x is plus or minus 3, there is no domain. But I want to know the domain. So how do we do that? So plus or minus 3 is negative infinity. So you want, say this arrow's point to negative 3 right here. Oh, sorry. This right here, my fist is negative 3. All right, so my fist is negative 3. So all the numbers before negative 3 are good. So that's from negative infinity to 3. The numbers bigger than infinity, or bigger than negative 3, to, what's my other point it can't be? This is what? 0.3. And then from 3 to infinity. So even though this includes every number, these parentheses here means not negative 3, not negative 3, not 3, not 3. So it's everything up to negative 3 but that, everything between the two 3's but not those 3's, and everything greater than 3 but not 3. Right? Now the range. This one always gets some people. Can your answers be negative? Yeah, if you have a very, very large, if you have a very small number here, like 1, your answers can be negative. Can your answers be positive? Yeah, big numbers, right? What can your answer never be? Because this is a 1 right here. Because you have no variables in the numerator, your answer can never be 0. 1 is never going to be 0, right? So your answer, f of x, can't be 0, meaning it's from negative infinity to 0 and from 0 to infinity. All right? Because you can't, no matter what you pick for x, say I pick 3, it's undefined. I can never set 1, the numerator, equal to 0, so it can't be 1. Once again, range depending on domain. Problem number 16, f of x equals tan x. So, first of all, what's our domain? Anyone? I gave you the picture here. See these dashes? These are called A words, asymptotes. Asymptotes are where you have undefinedness, okay? So, in this case, all right, and this actually goes on forever, but just in the graph we're dealing with here, x cannot be pi over 2 plus n pi. This is a little bit above and beyond what we're going to do, but it's always good to just show you a little bit extra. So what this means is, anytime I have a pi over 2 and multiply it by any whole number, right, pi over 2, except for 0, I believe, yep. So any number but 0 I multiply it by. That's why I could multiply it by 0. Pi over 2 plus n over pi. So any whole number here, so pi over 2, 3 pi, 5 pi, 7, 9, all those pi's, I have an asymptote. All right? I would have to write between these two, between these two, between these two, and everything would have parentheses. The range here, up and down, goes from negative infinity to infinity. All right? We're going to focus on these two, though. These are the two big ones. All right? Now, graph them. Go. You should do this. Should be done with this. I'll give you guys 10 seconds. Drink my coffee. Get a little bonus here. Slide 8 to 38. Ooh. Alright. Now, domain. Left to right, right? X values. Because there's an asymptote here, this graph cannot cross through the asymptote. If you counted there, you counted to 4. So x is everything less than 4, which is from negative infinity to 4. Range is up and down. This means you go down forever. This means you go up forever. From negative infinity to infinity, all real numbers. The little r. That's easy. All right, problem B. Domain and range. Domain. I count 2. From negative 2, everything greater than negative 2, so it's negative 2 to infinity. All right, range. Start here, go down. Even though this is going to level out, it's leveling out, it's still going to go down forever. So it's from 1 to negative infinity. All right. Now, because negative infinity is smaller, though you would write it as negative infinity to 1. Smaller number always comes first. Negative infinity always comes first. Positive infinity always comes back. Even though the graph looks like this, you go, oh, look at 1 to negative infinity. Actually coming from negative infinity to 1. All right. Got it? Next one. All right. Find the domain and range of these graphs. Let's see if you guys can do these. All right. Let's see. First one here, number 17. F is the green graph. G is the orange graph. So, range from the left to the right. So, negative 4 to 4. Brackets. Everything's brackets because they have closed circle. Up and down is -3 to 5. Look at that. See, I'm doing all these problems right now in my head. G, right here. You're going from -3 to 3. And the range is, once again, -4 to 4. All right. I don't know where my -4 went right there. Put a 5 instead. That's weird. All right. F of 4. That means what is my actual value at 4? Okay. So what is my y value at 4? This is f, so use function f. So when f is at 4, which right here, my y value is 5. See that? What is my actual y value when x is 4? What is my actual y value when the x is 0 on graph G? On graph G, x is 0 right here. Okay? So this is your x. X is 0. What is my y? 0. So my y is -1. All right? If you didn't get it, now hopefully you understand. If not, ask me in class. All right, so problem 18. Whoa. Another computer. Domain of f, left to right, is -5, 5. The range from here and up to there, -4 to 4. For G, my domain, -4 to 5. And my range, -4 to 2. All right, see, not too bad now. F of 0, what's my actual value at 0 of f? Right there, -4. G of -4, what's G of x at -4? Right there. Oh, look at that, -4 as well. See, happy now? You guys feel like you understand this a little bit? Hopefully you do. All right, now, we go back to the stuff that you don't like. See how I do that? Stuff that's easy, stuff that's not easy. So once again, we're going to find the domain based on the equations. Now, I put some rules up here just to help you guys out and guide you along. These rules are also in your packet to help you guys out. All right, now, find the domain and range based on the equations. Domain, the denominator can be 0 for a fraction. It cannot. So you cannot have a number over 0. There cannot be a negative number inside a radical. You go through those two rules, you're set. Range, based on domain. Dependent on the independent x variable domain. See, I made up for that earlier. All right, problem 19. What is my domain? Domain is, radical and denominator. So now it can't be two things. Can't have a negative under radical. And what can you have with the denominator? Denominator can't be 0. So if it was just a radical, you would have to be greater than or equal to 0 inside. So since it can't be 0, it wouldn't be greater than or equal to 0. It would just be greater than 0. Radical in the denominator can only be greater than. Subtract 2 from both sides, or add the x to both sides, it doesn't matter. What you end up with is x is less than 2. If I subtracted 2 and divided by a -1, when you divide a inequality sign by a negative, you would switch it. So you could do it either way. And by moving my x to the left, I had to move the less than sign with my x. So less than 2 is an open circle, and it's every number less than 2, from -infinity to 2. Now the range for this thing can't be a couple things now. Because there is no variable on top, it can't be 0, right? You need a variable on top to make it equal 0. Also, this number has to be greater than 0, which is positive. So since this is positive, the number on bottom can never be negative. It's always positive. Positives divided by positives are positive. So f of x has to be greater than 0. It has to be positive, and it can't be 0, so it just has to be greater than 0. Parenthesis, 0 to infinity. All right, this stuff takes a little while to get the hang of. Whew. Just got a denominator there. Denominator cannot equal 0. So x squared minus 4 can't equal 0. Add 4, square root, plus or minus 2. So, as I said before, all right, every number less than 2 every number negative 2, every number between negative 2 and 2, and every number greater than 2, but not including the 2. So, negative infinity to negative 2, negative 2 to 2, and 2 to infinity, parenthesis, parenthesis, parenthesis. Alrighty? Awesome deal. Range. Top can't be x, can't be 0, right? Also, this can't be a 0 right here. So 6 over 0 squared minus 4 is technically negative 1.5. Now, so it's from negative infinity to negative 1.5. Now, the reason it can't be bigger than negative 1.5, all right, if I pick the number such as, and 0 to infinity. The reason it can't be in here is pick a number between these two, like negative 1. If I pick negative 1, this becomes, well, you can never get negative 1. Because I would have to get this to 6, and 6 over negative 6. So I'd have to get this to negative 2, and I can't, just because of the, where it is. All right. That is for another more advanced lesson. These, you get some tricky stuff down here with the range. That's why I think I messed up with the range before too, but basic rules. We care more about the main. Well, I do. Bottom has to be greater than 2, right? Can't be greater than 0. Can't be equal to 0 because it's the denominator. Can't be negative because it's in a radical. Add 8. X has to be greater than 8. 8 to infinity. Range has to be greater than 0. 0 to infinity. Got it? All right. How are we doing? Doing good? Sure? All right, let's do these graphs. Go. Graphically, a lot easier than analytically. This graph right here. The asymptotes help you out here. The domain, from here to the left, from, what number is this? These go by 2, so this is 2. Everything less than 2, from negative infinity to 10. The range, from 0 to infinity. Not including 0, not including 2, because the asymptotes mean you cannot cross those places. This one, we're actually going to graph that graph later on this year. All right, when we get to what is it? Chapter 4. We're going to be able to graph these without a calculator, just with paper. All right, so 3 different domains. First one, from negative infinity to negative 2. From negative 2 to 2 is this one right here. And this one is from 2 to infinity. The range right here, negative infinity to, that is an asymptote running across there. So that's about 1.5. And from 0 to infinity. So you got like a little buffer there. There's nothing in there. Right here, positive 8 to infinity. And the range is from 0 to infinity. Now, I don't know if you guys realize this, but A, B, and C are the graphs of the last 3 things we just did. All right, this is the graphical representation of the numerical stuff. You found the domain and range for the other way. That's why all these 3 answers are the same as the answers for the other problems. Ah, gotcha. All right, going over what we had for homework. Domain and range of each function. Domain, it's just a regular polynomial. So the domain is all real numbers anytime you have a polynomial. Negative infinity to infinity. If you don't have a radical, or a fraction, all real numbers. Range, all real numbers. Whatever I plug in here, if I plug in a negative number, it's really big negative. If I plug in a positive, it's really big positive, so it's between the 2. 2 is a little tricky. Domain. Well, under a radical, can't be negative. So even though this one could be anything for this one can't. When can't that be a negative? When 2x can only be greater than or equal to 0. Okay? So, x can only be greater than or equal to 0, so that is bracket 0 and everything bigger than that bracket. Right? The range. This is the one that might have got it. Because this is 3 minus radical 2x, we said this number can only be what? positive. So when you subtract the positive number, 3 minus anything positive, is that number, your answer, going to go up or down from 3? What was 3 minus 1? 2. 3 minus 2, 3. 3 minus 3, 0. So your answer is going to be 3 in every number under 3. Okay, so when I plug 0 in here, the highest number, or the lowest number, f of 0 is less than or equal to 3 minus whatever this is, which is just 3. So it's every number less than or equal to 3. That's from negative infinity to 3. All right. Problem number 3, your domain. Well, the x is in the numerator, so it could be anything, all real numbers. Your range, x is in the numerator, anything, all real numbers. All right. 4 is almost all real numbers. This can't equal what, though? 0. So you can't have a number over 0. 6x minus 12 can't be 0. 6x can't be 12, and x can't be 2. Okay, so it can be any number but 2. So from negative infinity to 2, and from 2 to infinity. The range, no variable on top, so the range can't be 0. Negative infinity to 0, and 0 to infinity. You just got to asymptote at 0. All right? Whew! How you feeling? Tired? Domain. Can't have a negative under a radical. So x plus 1 has to be greater than or equal to 0. X has to be greater than or equal to negative 1. 6 doesn't matter when you're dealing with domain. So negative 1 to infinity. The minus means bracket. Now your range, this number always has to be what? 0 or positive. So does your range. 6 times 0 is 0, right? 6 times a positive number is positive. So say I typed in negative 1 into this equation. F has to be greater than or equal to 6 times radical 0, greater than or equal to 0, so from 0 to infinity. So this is just showing you how to do it both ways. I think the plug and check way is a little easier. If you want to do it the mathematical way too, you can. But then you just got to make sure you put the sign the right way. Problem 6. Can the answer be 0? Ooh, baby. All right, so bottom can't be 0, right? How do we factor this? First step is to take out an x. Second step, factors in negative 6 that add up to 1. 3 minus 2. X minus 2, x plus 3 equals 0. X equals 0. X can't equal 2. X minus 2 can't equal 0. X can't equal 2. X plus 3 can't equal 0, and x can't equal negative 3. So you have 3 things that can't equal. You have to go in ascending order. So the lowest number here is negative 3. So it's negative infinity to negative 3. Negative 3 to 0. 0 to 2. And then 2 to infinity. Look at that. What can your range be? Well, it can be 0, right? Because there's a 0 up top. Can't be 0, because look at x can't be 0. So I can't plug it in there. So my range is every number but 0. So negative infinity to 0, and 0 to infinity. Alrighty. Give yourself a hand. You guys are starting to get this. Alright, hopefully. Alrighty, problem 22, 23. Ooh, I'm sorry. Piecewise. You guys remember piecewise? We don't really work on this too much, but say you get a function defined by more one equation. So, what I want you guys to do is solve this. Oh, I put the graph on there already. Whoops. Alright, so problem 22. What you're going to do is, first one, you have the graph right here. It is from 1 minus x. So I put a graph at 1, go minus x, but it's greater than 1. So 1 is my lowest number, and then we go to the left. Now, the radical x minus 1 if x is greater than 2. All right. So I put in my 1. Radical 1 is 0. And you know what that graph looks like? 2. 2 minus 1 is 1. 5. 5 minus 1 is 4. Square root of 4 is 2. So it's like this. So that's what my graph looks like. Using being able to graph this makes this easier, right? I just plugged in numbers to get these points. So domain is negative infinity to 1 for this one, negative infinity to 1, but not including 1. And for this one, it's from 1 to infinity. Now, here's the deal. When you deal with domains, you combine the two, okay? Find domain for an entire piecewise, you combined all the domains. So with the piecewise, you take whatever this domain is, you add it to this domain. So the first domain, negative infinity to 1 with an open circle. The second domain, 1, closed circle to the right. So this whole domain would be, what? What would this whole domain be? Look at the graph. All real numbers from negative infinity to infinity. For range, 0 to infinity. That's not nested, that's just showing the other ones. All right? The top one is from 0 to infinity because it doesn't include 0 down here. This range does. Also combine the ranges. So what do you think we combined here? 0 to infinity. Piecewise. You're not really going to see piecewise. At least not in the beginning. All right, problem 23. Say you have 3 different functions you're doing, okay? You would have to find the domain of each function and just do that. So find the domain of each one of these individually. First one, use your denominator rule. The bottom can't be 0. So x cannot be negative 5. This one, this has to be greater than or equal to 0. Add 1. Divide by 2. X has to be greater than or equal to 1/2. And for 6, it can be all real numbers. I would plot these. Do you have to plot these? No. To find the domain for a multifunctional equation, use overlapping domains. So this is everything but negative 5. So it's from 0 to negative 5 and negative 5 to infinity. Right? This is everything greater than or equal to 1/2. Closed circle, greater than 1/2. This is all real numbers. So where do all these equations overlap? From 1/2 on. So your domain would be bracket 1/2 to infinity. Okay. The range. What do you think the range is? Well, type in your 1/2 into the equation. 3, 5.5 minus 2 times, this is 0, plus 6 times 0.5, and you get 0.55 minus 0 plus 3, 3.55. So the range is actually all the numbers that are, what do you think, bigger or less than this? Since these numbers go up, it'd be all the numbers that are up. Right? Because if I typed in 5 in this equation, this gets smaller, but this gets a lot bigger. All right? So it would be from 3.5 to infinity. Got it? A little tricky doing all this stuff. You want an easier problem? Of course you do. Here you go. All right. Next problem. Ready to this problem? What do you know about the numerator? We're good with that. What about the denominator? Cannot be 0. Radical has to be undefined. If it is a negative, so 2x has to be greater than 0. X has to be greater than 0. Parentheses 0, infinity. The range can only be positive and can't be 0, so it's every number. Can't be 0 because there's no variable on top. Has to be positive because the bottom's always positive. Positives over positives are greater than 0. X is, there you go, 1 over a positive number is positive. 0 to infinity. Got it? All right, let's look at B. Domain. Trick question. It's everything. All real numbers. Range. Not everything. Now, when I put numbers in here, this is going to get you. Say I put a 0 in here. This becomes 10, right? Say I put 1 in there. Did I put 1? Negative 2 times 1. 10 minus 2 is 8. Say I put a 3 in there. Okay? 9 times 2 is negative 18 plus 10 is negative 8. So I'm good with that, right? Say I put a negative 3 in there, though. Oh, I still get negative 8. Say I put a negative 1 in there. Still get 8. The lowest, the highest number this could be is 10. You can see how this is a negative. It means this is always going to subtract this, and since x squared always is positive, it's always subtracting a positive number. So 10, and then it just goes down, 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 down. No matter what number I plug in, positive or negative, the numbers go down. All right? So you always have to look. If you square it, you're squaring your domain, so it could trick you. Got it? All right. For the homework, these are the problems you had to do. Domain, polynomial, plug in all real numbers, right? Now, anytime you plug something in here, it's always going to be positive, except for 0. See? When you square a negative number, it's positive. So my answer is just going to be from 0 to infinity, as we just did with the last question. Problem number 2, domain, all real numbers. Once again, when I square all real numbers, they're positive, right? So positive number minus 5. So everything's going to be getting bigger than negative 5. All right, negative 5 is the lowest number. So it's from bracket negative 5. See, from negative 5 to infinity. Bracket negative 5 to infinity. This is 0, your answer is negative 5. If it's 1, your answer is negative 4. If it's negative 1, your answer is negative 4. If it's negative 2, your answer is negative 1. All right? Problem 3. 6x has to be greater than or equal to 0. So x has to be greater than or equal to 0. In this case, your answer always has to be a what number? A positive number. Positive numbers are 0 or positive. So, from 0 to infinity, including 0. Sorry. It can be 0 as well. This one. A little tricky here. X plus 3 has to be greater than or equal to 0. Subtract 3. X has to be greater than or equal to negative 3. Bracket 3, infinity. Now, in this case, very, very important. Negative sign out front, so negative, always going to be positive, or 0. So your answer is going to be 0 or negative, because a negative times a positive is always a negative. So that's from negative infinity to 0. All right? Problem number 5. Oh no, double, double. All right, first one, that has to be greater than or equal to 0. 1 minus x has to be greater than or equal to 0. So x has to be less than or equal to 1. All right, if you want to graph these to help you out to see where they overlap, or x is less than or equal to 1. I said it the same way, both ways is fine. So I have 0 here, I have 1 here. Closed circle, everything bigger. Closed circle, everything less. So the domain is between 0 and 1. So bracket 0, bracket 1. Now the range. What do you think? Well, these numbers can never be negative, right? If I plug 0 in here, 0, it's 1. If I plug 1 in here, the answer is 1. So is my answer always 1? No. If I plug 0.5 in here, it's 1.41, square root 2. So my answer is actually bracket 1, 1.41. And the reason this is, I don't want to really get into this too much, but if I put like a negative 1 in here, it'd be undefined, and then it just gets a little weird. So 0.5 is like, it's like a little mini parabola underneath. All right, once again, we'll get into that more later. I wanted to give you a little more difficult examples. All right, that makes sense? Hopefully it does. I'm at like the 1 hour here straight, so it's getting me a little bit. All right, and I'm only halfway there. Woo, this is gonna be a long lesson. All right, so all that stuff, if you set it equal to 0, x minus 2, x minus 1 equals 0, x can equal 2, x can equal 1. Now, that is okay. I foiled this. I think only 2 or 3 of you guys probably got this. Why did I do that? Well, here's the reason. Because I need to know when these are 0, that's fine. But when either of these is negative, that's not fine. So anytime x minus 2 is negative or x minus 1 is negative, that is bad. Okay, so anytime x is less than 2, less than 2, less than 1, Could it be greater than 2? Wait a second. 3, 9 minus 10. Oh, sorry. Greater than 2 or less than 1. The answer is bad. All right, so if I did 1.5 in here, it'd be negative. But if I did 1, 1 minus 3 plus 2, that's 0. That's okay. Say I did 0. 0 minus 0 plus 2, positive number, good. Say the 3, 9 minus 6 plus 2, good. All right? And why did I combine the domains there? Because it's not a piecewise, it's not a combined domain, it's just what you do when you have polynomials under radicals. F can be 0, can be plus or minus, so it's from 0 to positive infinity. All right, because it can be positive or 0. All right, ready for the next one? Let's stand up for a second. What I want you guys to do is graph a function. Whew. Next problem. How this works is quite simple. Asks, is the distance what? Anyone? I didn't hear you guys yelling. It is the directed distance from the what axis? The y-axis. F of x is the directed distance from the where? X-axis. Okay, so when we're graphing a function, your x is the distance you get from the y, and it makes a perpendicular line with the y. And I should say shortest or the directed, that's what it means. There. So, vertical line test. If a vertical line test passes through a graph more than once, it is, what if you pass through more than once? Not a function. Sorry. So you got f, x, f of x, your xy. Use the vertical line test to determine if these 6 things are functions or not. Need my caffeine and my soda to pep me up here. So, 2 hits the graph twice. 2. See how it hits the graph? This vertical line touches the graph twice, touches the graph twice. Is it a function? No, not a function. What about 25? No matter how many vertical lines I draw here, it only hits it once, 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 once. Guess what? Yes, sir, it is a function. Problem 26. Bet half of you guys got this wrong. 1 time. No times. 1 time. Well, what do you think? Function, not a function? It is a function. More than once. 0 is not more than 1. 0 is less than 1. Okay? This is a piecewise function. Problem 27. 1, 1, 1, 1, 1. Bam. Function. Problem 28. Another trick one. 1 time. 1 time. How many times does it hit the graph there? Once. Open circle means you don't touch that point. So 1, 1, 1. Is it a function? Yes, indeed. What about 29? Something with an asymptote. Does that asymptote make it not a function? Same as up here. Just because it doesn't touch it doesn't mean it's not a function. All right? Sketch. Oh boy. We're going this way. I forgot this is the long chapter. This is the fun one. All right, so identity curve. We're gonna graph a bunch of different graphs. First one is the identity graph. Do you guys remember what that is? F of x equals x. Y equals x. Do you remember to graph these? I'm just gonna go through them all. You can try them on your own. Everyone, like 12 of them. So 0, 0. When x is 1, y is 1. When x is 2, y is 2. When x is negative 2, y is negative 2. So it's just a straight line going through the origin. That's the identity curve. All right, a line with a y-intercept of 0, a slope of 1. Squaring. F of x equals x squared. What word would you use to describe that? A u or a parabola. Type in 0, 0. If I type in 1, 1. If I type in negative 1 squared, 1. 2 squared, 4. Negative 2, 4. The u or the parabola. All right? Absolute value. Remember what that graph looks like? Yell it out real loud. What's my last name begin with? V. It's a V graph. Absolute value of x. All right, means the graph always has to be positive. So it's like this, but instead of continuing down, it pops back up. So 1, absolute value of -1 is also 1. Absolute value of 2 is 2. Absolute value of -2 is also 2. The graph looks like a V. Rational. Do you know what rational is? That is a 1 over x. Way you graph a rational graph is, first off, if you plug in 0, 1 over 0 is undefined, you have a asymptote. If I typed in 1, 1 divided by 1 is 1. -1, 1 divided by -1 is -1. Now, do you know what these graphs look like? Think. Here's some hints. 1 divided by 1/4 is 4. 1 divided by 2 is 1/2. You getting the idea? Asymptote at 0, the graph can never equal 0. We know that from domain and range. Graph looks like that. All right. X4. Cubing. F of x equals x cubed. Way this works, very simple. 0, 0. 1, 1. -1, -1. Oops, sorry. 2, 2, 4, 6, 8. 2 times 2 times 2. All right, -1, -1, blah, 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 blah. And it looks like some people call it an S curve. Square root. Square root. Square root of x. Okay, that's a radical curve. 0, 0, 0. Square root of 1 is 1. Square root of 1, 2, 3, 4 is 2. Right? Can't do square root of negative, so you have nothing over here. Answers can never be negative, you have nothing over there. For some reason, as long as they teach us, I want to agree, people call it an R curve. Still can't see it. All right, sine. You remember sine and cosine? We're going to be having fun with this when we get to like lesson 5 of this chapter. F of x equals sine x. Now, remember, use radians. If you type in sine 0, you get 0. Sine, now this is 2 pi. That's typically the period of this. So you have pi over 2, pi, 3 pi over 2, and the same thing, negative. Pi over 2, sine pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. Sine of 2 pi is 0. And you go the same way the other way. And it is a wave function, pretty much. And it continues on and ever. Whatever the period is, it goes up to 1, down to -1, and it keeps on going through the zeros. If you have sine, you have to have cosine. Cosine is the same as the sine curve. It's just shifted over. Okay, so it starts at 1. So it's shifted to the right pi over 2. So then it goes down to 0, down to -1, up to 0, up to 2 pi. If you go backwards, 0, -1, 0, 1. And the graph looks kind of like a W if you just go from here to here. It goes down, up. But this is your sine curve, remember? So if I cover this, it looks just like the sine curve. If I covered, let's see, this and that, it looked like the cosine curve, right? All right. Now that we did some curves, back to domain and range. Like that, bounce you back and forth. Thought it was going to be easy again. All right, so first one, this is a radical. This actually is easy. 3x has to be greater than or equal to 0, right? Divided by 3x has to be greater than or equal to 0 from bracket 0 to infinity. The range can be 0 and can also be any positive number. So it's from greater than or equal to 0, bracket 0 to infinity. Good? This domain, this is easy. X plus 4 can't be 0. Number over 0 can't be infinity. So x plus 4 can't be 0, subtract 4. X cannot be -4, so it's -infinity to -4 in union with, right? -4 to infinity. All right, I got to put some more unions in the other ones. All right, range. My range. Answer can never be 0 because the numerator doesn't have a variable in it. So it's from -infinity to 0 in union with 0 to infinity. Yes, it can be negative. Yes, it can be positive. If I pick a number greater than -4, it's going to be negative. If I pick a number, less than -4, it's going to be negative. If I pick a number greater than -4, it's going to be positive. All right? Got it? All right. Back to graphs. Now, the reason do-nows are thrown in there like that is this is where the lessons split in the class. So if you missed a couple classes, every time you see a do-now, that's pretty much where one class would end. So next one, transformation of functions. Ooh, it's like 2018. Let's pick it up here. Original graph. So we have f of x equals x squared. Original graphs are called what type of functions? Think of them. P-A-R. F of x equals f of x. It is your parent function. It is the function that everything goes off of. All right, so we're going to go everything off the function x squared. Now, if you want to do a horizontal shift, you could add a minus something inside the function. So if I have f of x equals x minus c, you are shifting it c units to the, which way is that shift? When you do a minus, it is a shift to the, very good, you said right. And how many are we shifting it in this case? 3. So 1, 2, 3. We take the whole graph and we shift it over 3. So this is the weird thing. Minuses mean shift to the right when you're dealing with horizontal. X plus 3 squared. So that is your parent function, f of x plus c, right? Because we're taking the function, which is x squared, and we're adding something inside the function. And this one's going to shift c units to the, plus means to the left. So I take this function right here, which I kind of moved, and I move it 1, 2, 3 to the left. Oh, this guy should be slid over. I gotta fix that. All right, so pretend this is on the origin. My parents off, but 1, 2, 3 to the left. Got it? Good. Right here. X squared minus 2. So you take this function right here. Minus 2 is a vertical shift. Notice you're not inside the function. You take the function and you subtract 2. So your y value goes 2 down. So that's c units down. So we take this parent function and we shift it 2 down. All right? Parent function here. If you add something, if you take your function and you add a number to it, c units up. So that function slides up twice. This problem, reflection. The reflection doesn't really work terribly wonderful with the parabola, sorry, but I didn't want to switch graphs midway through. F of x, negative. If the negative is outside the function, if it's a negative f of x, you reflect about the x-axis. X-axis is this axis right here, so everything on top moves to the bottom. It's your reflection. If your negative sign is inside the function, this is where I say I'm sorry, it's reflected about the, where are we at? Y-axis, okay? So what that means is this reflection actually reflects onto itself, so it looks the same. But if I had a graph that say look like this, it would just look like this on the side. All right, so you're reflecting it about the Y. If I do a double reflection, one on the inside and one on the outside, okay? You have two negatives, so you change the inside function and you change the outside function. You're reflecting it about the origin. Now, in this case, the origin just looks like a reflection like this because it reflects about the Y and then the X. But say it just went up here and the graph was just this right here. Our reflection about the origin would be reflected and then reflected, so it would be down. All right? So technically, this piece is here and this piece is over there. Got it? All good? All right, let's see if you guys now can graph this. I gave you guys some hints right here. Except for here, I'm going to see if you guys remember that one. Problem 30. Go, I want you to graph that using the functions. All right, should be pretty much done with this problem. And so you're going to start with your original parabola. All right. And now, you're going to look at your pieces of the things that you're doing to it. First up, this, the negative inside means you move it to the right 2. This plus 3 means you're moving it up 1. So I'm going to take this, and I take this point, I go 1, 2 to the right, 1, 2, 3 up, and I have a new vertice. My graph, 1 over 1 up, it just looks like the same parent function. All right, that's it. See how easy that was? All right, any questions? (31) Now Now the x cubed curve looks like an S. Okay, I don't know why it's not there. Now you have a negative out front. That negative out front means you reflect over the x-axis. The minus means after you do that, so when I reflect over the x-axis, instead of this one going up, it goes down. Instead of this one going down, it goes up. Next thing I do here, I'm going to move it down 1 because the minus is outside the function. So all the points move down 1. This moves down 1, and I have my piece and my piece. All right. 32. Draw your parent function. Minus, or sorry, let's do the inside first. Or minus reflect about the x. This is my x, so it's going to go a downward reflection. Minus 1 means it moves to the right 1 because it's inside. So this piece goes to the right 1. And then the plus 2 means it moves up 2. So right 1, up 2. That's going to be my new start point. And I draw a pitch. That's it. Ready to do some more? Ah, there you are. You came in late to the party. All right. Problems 33 and 34. Let's go. I left the parent functions on these things for you guys to make it easier for you. All right, let's see. The negative sign right there means flip about the x-axis. All right. Minus 2 on the inside. What does that mean? And the plus 4. Right 2, up 4. Right 2, up 4. 1, 2, 3, 4. And we're going to take this figure and we draw it. And there we go. We're it. Series those. 34. Got my parent function right here. Negative means I'm going to do what? Reflect it about the x. X plus 1. What am I doing? Right 1, down 3. Sorry, left. Plus is left. Left, down. And then I got the graph. And that's it. See? This stuff's easy, right? Better than domain and range? Alright. Are we all good with this stuff? Next one. Classification and combinations of functions. So, 3 types of classifications. Ready? First type, algebraic functions. You know what an algebraic function is? Polynomials. Right? Just run straight across. Have coefficients in front of them. Variables raised to the power, they're all the same variable. You have radicals. What are radicals?
Sorry, I didn't find a device named front room same variable.
Oh. See, even my Alexa wouldn't help me out. So radical is a radical sign of an equation, of a function. You have rational numbers. Rational numbers are fractions. Okay. Second type of functions, trigonometric. Remember your good old geometry? Hopefully, maybe luckily I was your favorite teacher. You got me in geometry too. You have your sine, cosine, tangent, cosecant, secant, cotangent. All right, those are all your trig functions. And lastly, the least popular is the exponential and logarithmic. By least popular, I mean it's the one we use the least in this class. We use mostly this, some of this, and a little bit of that. So that's like raising a number to an exponent. That's like having an e to an equation, a function. That's like having a log, right? Logarithmic function here. Or a natural log, right? Remember all this fun stuff? We don't really focus on this too much. We'll probably do a little bit in the pre-calc section and then go over derivatives, integrals of them, but nothing really crazy. Wait till later on in calculus, though. Then it gets good, especially when all the numbers disappear and you're left with matrices and the letters. All right. Classifications of polynomials. Number 1. First type of polynomial has the 0th degree. Meaning f of x equals a just equals a constant. So it's the constant function. So for instance, f of x equals 7, f of x equals 12, f of x equals negative 18, stuff like that. What comes after 0? First degree. Then you're going to be a first degree function. F of x equals ax plus b. All right, that'd be a function like a linear function. F of x equals 6x plus 7, something like that. What comes after 1? The second degree. We're not going to go through all of them. We're just going to go through a couple. F of x equals ax squared plus bx plus c. Right? F of x equals 1/2 x squared minus 7x plus 12. See that? Next one. Quadratic function. Then after the second degree, you have the third degree. Third degree. You throw a cube on there. Ax cubed plus bx squared plus cx plus d. All right? Cubic function. The a's, the b's, the c's, and the d's are just coefficients. Then you have the fourth and the fifth. All right? Same exact stuff. Just keep on throwing on variables. Okay, at any one of these points, every one but the leading one, except for the 0th degree, all of this stuff right here can all be zeros as your coefficients. You don't need them all. You just go with what the leading degree is. All right? Got it? Any questions? All right, do now. Let's go. I want you guys to write the equations of these graphs. Now you're going backwards based on what the graphs say. You should start by saying, I see the parent function, quadratic. Definitely. Now, what do we notice about the quadratic? We're going to move it from its origin. I have to move to the left 2, and I have to move. So that's a plus 2 inside, right? Then what do you move? How many up? I have to move up 3, right? So I add the 3 on the end. Lastly, is that a quadratic? No, it's an upside down quadratic. So what do I have to do? Flip it over the x, put a negative out front, and bam, there's my answer. See that? That's pretty easy, right? Now you guys can classify all this stuff. All right, what does this one look like? Looks like a radical to me, right? Whoa, f of x equals radical x. Now, what are you doing first? You moving it left to right at all? Nope. But what am I going? I'm going up 2. So radical x plus 2. Am I flipping it over the x? Nope, I'm flipping it over the y-axis. So where's the negative go? On the inside, and that's my answer. See? Last one, that is a cubic function. 1, 2, 1. So I slide to the right 2. Not a plus 2, but a minus 2. X minus 2 cubed. I also slide down 1, so I throw a minus 1 on the end of that. Let me pop a minus 1 down there. And then lastly, do I flip it at all? Yes, it is flipped over the x-axis. So it's negative x minus 2 cubed. Right. You got it, right? All right. This was your homework. The homework was fairly simple. This was dealing with graphs. Had to match the curves. You're using the light blue f of x parent function and doing all this stuff to it. None of these are the actual functions. These are all obviously absolute value functions, but it's just looking. So the plus 5 right here means I'm going to take this function and move it 5 to the left. 1, 2, 3, 4, 5. My answer is D. The minus 5 on the back means I'm going to take this function, I'm going to move it 5. 1, 2, 3, 4, 5. Down. That answer is B. The negative on the outside of this means I'm going to flip it over the x-axis. And then I'm going to move it down 2. And I'm going to go move it to the left 6. So take it. 1, 2, 3, 4, 5, 6. 1, 2. And flipped has to be C. Right 4, flipped over x. 1, 2, 3, 4. And a flip. Obviously it's A. See, this stuff was easy. You guys were complaining how hard it looked. Left 6 up 2. 1, 2, 3, 4, 5, 6. 1, 2. Obviously E. Right 1 up 3. 1, 3. G. All right, and that's how you do it. Problem 7, 8, 9, and 10. Way you graph these. Also very simple. This is going to be a parent function of a parabola. To the left 2. And flipped. Cubic, S. All right, so we got our S here. Plus 2, plus 1. Left 2, down 1. Left 2, sorry, up 1. No flips, so it's just... Number 9, radical. You got your R. Don't call R. All right. Right 1, down 3. That, and no flips. That's your answers. All right. Told you it was easy. Okay. Definition of composite functions. Last 2 lessons. Composite functions. Very, very, very important. This is probably one of the more important lessons that we will be doing in pre-calculus. This and domain and range. Domain and range are very essential for when we do limits in chapter 2. Composition of functions are very important when we do chapter 3 on derivatives and chapter 4 on integral. Chapter 5 on integrals. I lost my chapters here. The reason for that is you have to break up the pieces and derive each one's or integrate each one's individually and then put them back together. But you have to understand what they look like to begin with. So, let f and g be functions. The functions is given by f of g. Okay? All right, this is f of g of x. Is called the composite of f with respect to g. The domain of f of g is the set of all x in the domain of g such that g of x is the domain of f. You probably heard blah, 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 blah. Understandable. Let me break it down easy. F of g equals f of g of x, as I said before. All you do is you're going to plug the g of x into the x value of f of x. Whatever g of x equals, you take that and you put in the x for your f of x. You're going to put it inside. So, here's how it works. F of g is different than g of f. So, first thing, you're going to work from the right to the left. I take whatever's on the right and I plug it into the piece in the left. So, this is 2x minus 3. I'm going to plug in for x whatever g of x is. So, it's 2 times g of x minus 3. G of x happens to be cosine x. So, I take my cosine x and I plug it in. So 2 cosine x minus 3. And then my last step is to circle my answer because I'm done. G of f. Now, I have g, which is cosine. I'm going to take my f of x and plug it in there. So cosine of whatever f of x is. What is f of x? 2x minus 3. Cosine 2x minus 3. Stop. You're done. That's it. Boom. Good? Let's go. 6 problems. Let's get it going. All right. F of g. Take f, plug g into it. So 3 times g of x plus 2. 3 times 5x minus 1 plus 2. Distribute the 3. 15x minus 3 plus 2. Negative 3 plus 2 is minus 1. And that's your answer. All right? I'm going to move now. All these 3 go for these. Okay, so f is going to be plugged into g. So 5 times 3x plus 2 minus 1. 15x plus 10 minus 1. 15x plus 9. 10 minus 1 is 9. Now, f of g of f. 3 of them here. So the first thing you have to do is you have to find g of f. You're going to work your way from your left to the right. But what do we already know? G of f equals 15x plus 9. We already know that. So g of f is 15x plus 9. How do we know that? We solved for it already. Now we're going to take g of f and we're going to plug it into f. 3 times x plus 2. 3 times g of f plus 2. 3 times 15x plus 9. 45x plus 27. 27 plus 2 is 29. That's your answer. All right. Better be getting this. All right, next one. Go. Pause. Play. Good. F goes into g. X squared plus 2. So f of x squared, minus 2. 5x plus 2 squared minus 2. 5x plus 2 times 5x plus 2. The answer is not 25x squared plus 4. It's 5x plus 2 times 5x plus 2 minus 2. 5x times 5x is 25x squared. 5x times 2 is 10x. 5x times 2 is 10x. That gives you 20x. 2 squared is 4 minus 2. 4 minus 2 is 25x squared plus 20x plus 2. H, the g goes into the h. 2 over g of x minus 1. 2 over x squared minus 2 minus 1. Negative 2 minus 1 is negative 3. 2 over x squared minus 3. Bam! F of h. F. H goes into the f. 5 times this stuff plus 2. 5 times 2 is 10. 10 over x plus minus 1 plus 2. Leave it like that. I don't care. If you want to make it all special, you can make the top 2x minus 2 and 2x plus 8 over x minus 1. Who cares? It's fine, man. All right. 43, 44. Go. A little more difficult. A little more difficult. All right. Done. Take your g back. This first. All right. Watch. Don't care about this. Just the g and h. So the h goes into the j. So it's 2 times h of x squared. 2 times 2 over x squared. Square the numerator, square the denominator. 2 squared is 4. 2 times 4 over x squared. 2 times 4 is 8 over x squared. You're going to take your 8 over x squared and plug it now into your f. Negative 2 times 8 over x squared plus 6. Negative 2 times 8 is negative 16 over x squared plus 6. Boom! You good? This one. Work your way from my side to that side. F goes into h. So h of f equals 2 over f, which is negative 2x plus 6. You could divide all three of these by 2. 1, x, negative x, and 3. Always reduce to simplest forms whenever you can. You can't drag the negative to the front because then it would imply that this 3 is negative as well. So now I'm going to take my h of f and I'm going to plug it in for g. 2 times this stuff squared. 2 times 1 squared is 1. Negative x plus 3 squared. Okay? Negative x squared is negative x times plus negative 3x plus negative 3x plus 3 squared. 2 times this stuff, the 2 just goes on top. 2 over x squared minus 6x plus 9. So we got these first 3, and now we're going to plug it back into f. Negative 2 times this stuff plus 6. Negative 2 times 2, numerator times numerator, is negative 4 over this stuff times 6. That's fine to leave it like that. And then finally, you're going to take all this, and you're going to plug it back into g. 2 times this stuff squared. And the last step is, you can just leave it like that. All right, if you really wanted to reduce it, you can. You can distribute the 2 into both of this stuff. No, you can't. You would have to foil this piece, and then you would have to multiply it by the 2 after you foiled it. All right, just leave it like this. Why waste your time doing all that weird, not weird stuff, but hard work. All right, real good? Ready? 2 more. Oh, actually, no, this was a do now. 1.3g. Oh, last do now, last day of the lesson. All right, it took me only how long, Mile? Hour and a half. I get this under an hour, 50 minutes, I guarantee it. All right, so take g of x, plug it in for the f. G of x squared, 3x plus 7 squared, 3x plus 7, 3x plus 7 is 9x squared plus 42x plus 49. You can also use this formula, a plus b squared, a squared plus 2ab plus b squared, minus 4. 49 minus 4 is 45. All right, h of f. Take your f, plug it in for your h. Negative 1 over 2 times this stuff. Negative 1 over 2 times x squared minus 4. Distribute the 2. 2x squared minus 8. And boom, you're done. Oh, shoulder. All right, c, it's a triple. Take your f, plug it in for g. 3 times x squared minus 4. 3x squared minus 12 plus 7. Negative 12 plus 7 is negative 5. Take this, and you're going to plug it into your h. Negative 1 over 2 times 3x squared minus 5. Distribute my 2. Negative 1 over 6x squared minus 10. That's it. There's your answer. Awesome, awesome, awesome. Ready to go to some more problems? All right, let's go. Lots of composites right here. Like I told you, most important part of the lesson. F of h. Take your h, plug it in for f. Negative 4 times 2 over x. Negative 4 times 2 is negative 8 over x minus 6. That's it. H of f. Take your f and we plug it in for your h. 2 divided by whatever f is, right? Wait, this goes in for the x down here. 2 over negative 4x minus 6. Divide all of these by 2, because you're just reducing. All the pieces have to be divisible by it. So you got 1, negative 2x minus 3. G, plug it into f. X squared, just plug it in there. That's an easy one. Negative 4, x squared minus 6. Negative 4x squared minus 6. All right. G of f. G. F. F goes into the G. Showing you how these two give you different answers. You get negative 4x minus 6 squared. Negative 4x minus 6 times negative 4x minus 6. Let's try the thing I told you. A plus b squared is a squared plus 2ab plus b squared. Let's see. 16x squared plus 48x. Oh, you just multiply these two. Plus 36. Good. I'm getting this by 16x squared plus 24x plus 24x plus 36. Got it? This one. H of f. We already said what it was. Where are we at? Give it to me. Right? That's h of f. Next one. Plugging in for the g. It's squared. 1 squared. 4x squared plus 12x plus 9. Good. Take this. Plug it into the f. Negative 4 times all that stuff. Negative 4 goes in the numerator. The g. Oh no! Square it all. Stop there. All right. If you want to FOIL it, FOIL it. If you don't, you don't. It's up to you. All right. You get negative 16 over this squared plus 48 over this plus 36. All right. All right. 50, 51. Let's go. G. Done. Pause. Play. How you doing? Good? Awesome. All right. G goes into F. 3 times x squared plus 4 plus 7. Distribute 3x squared plus 12 plus 7. 12 plus 7 is 19. This goes into the H. 3x squared minus plus 19 minus 12. 12 minus 19 is 7. And boom, that's your answer. H goes into the G. Square this. X squared minus x minus 12. X minus 12 plus 4. X squared minus 12x minus 12x plus 144 plus my 4. 144 plus 144 plus 144 plus 4 is 148. I take this and I have to plug it into the F. 3 times this plus 7. Distributed 3. 3x squared minus 72x plus 444 plus 7. 444 plus 7 is 451. 3x squared minus 72x plus 451 is indeed my answer. How's your composition skills coming along? Good? Awesome. All right, now, finally, we're going to test for some odd and evens. All right. Let's finish this up with some good old odd evens. Forgot about these. What do we got? Oh, 5 size. Test for even odd degrees graphically. If it's an even graph, the arrows go in the same direction, both up, both down. Here's the key though. They can both go up, they can both go down. What do you notice about both these graphs though? They have to be, I'll get to that in a second. If you're an odd degree, the arrows go in opposite directions. Down, up, down. Okay, so they either come from infinity and go to infinity or go to infinity and come from infinity. Wait. Yeah, I think I said that right. All right, so in both these cases, though, they need to be symmetrical. If they're not symmetrical, they can't be odd or even. Now, What are these symmetrical about, these two? They are symmetrical about the, where's the green line? The y-axis. These are symmetrical about the, not the y, not the x, they're symmetrical about the, or not orange, the identity line, y equals x, which is the origin. Look at right down, left up, right, left, right, up, left, down. See that? Right, up, left, down, right, up, right, down, left, up. See? Origins. Let's go do some tests. So the way you test for odd and even degrees analytically. First thing, you're going to plug in negative x for all the x's, and you're going to compare the equations. So first one, if it is even, f of negative x equals f of x. Ooh. If it is odd, f of negative x equals negative f of x, okay? So the function, if you plug in a negative x, is going to be the same exact function if it's even. The function, if you plug in a negative x, is going to be the opposite, so all the signs are going to be different. Seems easy enough, right? So let's try problem 52. If I plug in a negative x here, negative x to the fourth plus negative x squared. A negative number to an even power is always positive, so you get x to the fourth plus x squared. What do you notice about original function and new function? They are the same, therefore they are even. See, that wasn't too bad, was it? What about 53? Let's plug them in. Negative x to the fifth minus a negative x. That turns negative. Minus a negative becomes a positive. So let's look, compare. They're obviously not the same. Positive, negative, negative, positive. Since both sides, since all the functions inside this equation are different, they're all opposites, that means this holds true, so it is indeed an odd function. All right, 54, 55, and 6, go. All right, let's check your answers. Negative x to the third minus negative x. Negative x to the third, positive, negative, negative, positive. They're both different. It is odd. This one, 2 negative x to the sixth. Negative to the sixth power becomes positive. So it's 2x to the sixth minus 9 stays the same. They are exactly the same equation, so it is even. All right, even, odd, odd, even. What do you think the last one's going to be? You're wrong. Just joking. Hopefully, right? All right, so if you plug in the negative number, negative x to the third is a negative, negative x squared is a positive. So you got negative, which is different. But you got same and same. So since you have more sames than difference, do you think the answer is even? No, it's either all or nothing. Since it's not all the same, not all different, it is neither odd nor even. You don't have to be odd or even. Most of the time, you're not. All right, we good? Awesome. Now, let's go determine odd, even, or neither. All right, first one, what do you got? Looking at the picture. Both go down, symmetrical about the y-axis, so it would be an even function. What about 58? Both go up, symmetrical about the y-axis, and it would be a even function. Both go up, symmetrical about the y-axis. It would be an even function. All right, what about this one? We got an up, down. Is it symmetrical? Let's check. Over, up, over, down, over, down, over, up, over, up, over, down. All right, that does look symmetrical about the origin to me. And your answer would be an odd function. Now let's check it numerically. Plug in the negative x. Negative x squared is positive. Positive. So you got x squared, 4 minus x squared. Same exact function, so we're back to even again. A lot of evens. Plug in negative x cubed, because it is a cubed root. That's 3. You're allowed to have a negative under a odd radical. Pull the negative out front if you'd like. You don't have to, though. Positive, negative. Oh, that is a odd function. Trick question. Didn't tell you about trig. Let's see if you can figure it out. And did you? When you plug a negative in here, it's actually neither. This would be sine negative x and the whole thing squared. Even though you think it would be symmetrical, because of the squared, it would be unsymmetrical. All right, I got into the graphing class, but I don't feel like getting into it now. All right, when you plug in a negative number here, that becomes negative 10x. That becomes positive, so it's negative 10x minus 3x squared. Different, same, No good. That's a neither. All right. What do we got? Only a couple left. Oh, we're almost there. All right. Let's go back. Functions. Composites. Go. All right. Let's see what we got going on here. First thing, plug your G into your F. 1/2 of that stuff squared. When you square that, you get a squared plus 2ab, b squared. And then you do half of this, 8, negative 32, and 32. Take this, you're going to plug it into your h. 2 times this stuff, plus 14. 16, negative 64, 64. The only thing you can combine is the numbers. 64 minus 14 is 78. 16x squared minus 64x plus 78. All right? Awesome. This one, plug the h into the g. Negative 4 times 2x plus 14. Negative 8x minus 56 plus 8. Negative 56 plus 8 is a negative 48. You're going to take your g of h and plug it into f. 1/2 of that stuff squared. Blah, 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 blah. 64x squared. That times 2 is 768x. Negative 48 squared is 2,304. Half of all these numbers. What do you got? 32, 384, and 1,152. Right? Not too terrible, right? Oh, GGHH. So you put h into h. You're going to put h into itself. So 2 times 2x plus 14 plus 14. 4x plus 28 plus 14. 28 plus 14 is 42. Take this, put it into the g. Negative 4 times the stuff plus 8. Distribute negative 16x minus 168 plus 8. This becomes negative 160. And then you're going to take this and put it into g again. Negative 4 times this stuff plus 8. 64x plus 640 plus 8. Negative times a negative is a positive. Negative 64x plus 648 is your final answer. Don't you feel good when you get them all right? I do. All right. Now, this is going to be an extra problem. We did not go over this in class. This is just to show you where the word problem is and how we can do a word problem, all right? So I'm going to go through this fairly quickly, but if you have any further questions, just come to me and I'll explain it to you. This is where this question would be used in a real-life situation. A lot of people get boxes nowadays, right? Amazon Prime, best way to shop, right? Especially nowadays. But support your local businesses, more important. An open box, maximum volume to be made from a square piece of cardboard with 24 centimeter sides is shown below. So what that says is, each one of these sides is 27. So you take a flat piece of cardboard, and you're going to fold the ends over, and then you're going to fold it up to make a piece of cardboard. So if this whole entire side right here is 24, this piece is 24 minus the corners here, x and x. So since it's x units high, 24 minus 2x means the whole entire side is 24. Now, what is the volume of the function? Volume is length times width times height, right? So what's the length here? The length is 24 times 2x. The width is 24 times 2x, and the height is x. All right, now you could have came up with this equation on your own, but like I said, I don't want to really spend tons of time going over this. But they would actually use this to find out what value of x saves them the most money when making these cardboard things. That's why you notice sometimes you buy something really small and it comes in a bigger box. That box is actually cheaper to make than a box that's smaller. You have to FOIL here. 24 times 24, 24 times 2x, negative 2x times 24, negative 2x times that, and that comes out, and it's times x. You take your x, you're going to distribute your x in there. And the actual volume of a box that has 24 centimeter sides is 576x minus 96x squared, right, plus 4x cubed. Now, your domain for your volume, you would think is from negative infinity to infinity, right? Because it's a polygon, but it's actually not, okay? You can't have 0 because the side has to have some type of height, and you can't have a negative side for x, right? So it has to be greater than 0. Now, what's the biggest number x can be? What do you think? Use common sense. So you would think, okay, so 0 to infinity. That's not true either. You can't have an infinite number for x. The maximum height here is 24. 24 is the maximum height, right? No. It's actually, so you say, oh, 0 to 24. But that's not true, is it? Because what happens here is 24, it has to be a little less than 24. So the width could be 24. So your maximum height, since you have to have two x's, would actually be 12. So I'm getting this right here. You actually have 24 minus 2 times 24 is negative 24. And x has to be less than 12. Okay, the reason for that is, if both of these are 12, all right, your height's 12, right? 12 and 12, this would be 0. So you have to be just a little bit less than 12. So negative infinity to 12, well, you can combine these two. And you're just going to go with 0 to 12. All right? So I combine these two, and then I use these two combined to get this one. Make sense? So that means the smallest value has to be a little bit bigger than 0. The highest value has to be a little bit less than 12. So can I find out what value of x gives me the most space in the box? How do you think you do that? We go to this. Here's my volume. We know that you go from 0 to 12. So what height gives you the greatest volume? So what can you do here? You actually have to do a plug and play. Take in some values for your height and plug them in. So my height's 1. I plug them in here. You get a volume, and your volume is 481 cubic centimeters, right? Because this was in centimeters. All right, so pick another one. You guys try to figure it out. I just want a whole number, though. All right, so say you picked another number, 7. I'm just picking random numbers. 700. Okay, good. So I know it has to be bigger than 1, bigger than 7. Let me pick 6. Why did I pick 6? Because I felt like it. Plug it back into this equation. 864. Okay, so now what I'm telling myself is the number cannot be bigger than 7, can't be bigger than 6. So I have to take 6. I have to go between 6 and 1. All right, let me pick 8. 512. Why did I pick 8? To prove my point. The higher I go away from 6, the smaller the volume gets. I don't want to do that. So let's pick a number less than 6. Let's pick 5. 980. Ooh, that's good. That means I'm getting closer. Maybe 5 is my answer. Let's pick 4. 1024. Ooh, that might be my answer. Maybe 3. Feeling lucky? I picked 3. 972. Okay, so look what happens. As I go to 4, the answer gets bigger. As I go to 3, the answer gets smaller. So if I pick 2, the answer would probably even get smaller than this. So our answer is going to be 4. So when my height is 4, 4 and 4 of my box, my height is the best. So that means that the height's 4, and then the width would be 16. All right? Oh, so length and width would be 24 minus 2 times x, which would be 24 minus 8. I didn't realize I put that. So my length and my width would both be 16. So a box that is 16 by 16 by 4 would be the box that gives me the greatest volume. And I just use domain. I use plugging stuff into functions here. I didn't really use composite. I used some algebra. I used all that stuff to solve this word problem. You won't have to really do that in this class. I just wanted to show you there is more to math than we're going to be covering. But all we did today really was we did functions. We did their graphs. This was a long lesson. This probably took over a week to do in class. You could fast forward and rewind all this stuff, but we found out what functions use notation to represent the functions. We did domain and range. Very, very important. Sketched some graphs of functions, told how they transform, a little review. And then the composites and the combinations of functions, also very important, also good review. All right, so up to 1.1 to 1.3. We'll do a review next. We'll have a test on it, first test of the year. You guys will all get A's. And those of you that are not comfortable may leave, but hopefully you guys will stay. So until we go over the review, have a good day.